In this video, I'll be showing you how to use the definition to compute definite integrals. For this example, we'll use the function f of x equals 2x squared minus 1 on the interval from 1 to 3. So, we'll be eventually computing the integral from 1 to 3 of 2x squared minus 1 dx. But before we get to that, let's compute a few things that we're going to need for the Riemann sums. Now remember, delta x is by definition b, which is 3, minus a, which is 1, over n, which is 2 over n, and x sub j is a, which is 1, plus j times delta x, which is 2 over n, which will shorten to 1 plus 2j over n. So, using that definition, we'll look at RHS sub n, which is the sum as j goes from 1 to n of f of x sub j times delta x, which is the sum as j goes from 1 to n of 2 times 1 plus 2j over n squared minus 1. Now that's f of x sub j. Remember, f of x sub j gets multiplied by all of delta x, so we need to be sure that gets grouped together. And there we go. And we'll multiply by delta x, which is 2 over n. Now, let's multiply some stuff out. We get the sum as j goes from 1 to n of 2 times, now I'm going to multiply the 1 plus 2j over n in parentheses squared out, and when I do, I get 1 plus 4j over n plus 4j squared over n squared minus 1, grouping appropriately, times 2 over n. Now let me go back and make sure we caught all that. When you multiply a binomial by itself, so we've got the 1 plus 2j over n squared, that's the first term squared, 1 squared is 1, plus 2 times the first term times the second term. 2 times the first term times the second term, it's 4j over n, plus the second term squared, that's 4j squared over n squared. So let's multiply out some more. We get the sum as j goes from 1 to n of, let's group again, 2 plus 8j over n plus 8j squared over n squared. Now I've got this minus 1. But over here in the front I've got a plus 2. And 2 minus 1 is 1, so I'm going to go ahead and combine those. I'll erase that 2 and draw in a 1. So that's what we get when we fully multiply out f of x sub j. Now we're still multiplying by 2 over n on the outside. Now let's go ahead and multiply it out. We get the sum as j goes from 1 to n of 2 over n plus 16j over n squared plus 16j squared over n cubed. Now, I know that I'm going to need a new sheet of paper, so I'll go ahead and start that. I'll recopy what we just had. RHS sub n equals the sum as j goes from 1 to n of 2 over n plus 16j over n squared plus 16j squared over n cubed. Now what we've got is a sum, and all the terms in the sum look like a sum of 3 terms. There are pluses in the middle, so I can use that fact to break this up into 3 sums. It's the sum as j goes from 1 to n of 2 over n plus the sum as j goes from 1 to n of 16j over n squared plus the sum as j goes from 1 to n of 16j squared over n cubed. Now, remember the index, here in this case it's j, that's the letter that we're using to tell what number of the term is in each sum. That j is the variable inside these sums, which means the n's are constants inside the sums, and so are the 16s and the 2. So, remembering that we can pull constants out of sums, that's the distributive property, we can rewrite this as 2 over n times the sum as j goes from 1 to n of 1 plus 16 over n squared times the sum as j goes from 1 to n of j plus 16 over n cubed times the sum as j goes from 1 to n of j squared. Now, we can use the formulas that we've learned to replace these sums with formulas just involving n. The first one's easy. We have 2 over n times the sum as j goes from 1 to n of 1, that's n, plus 16 over n squared times the sum as j goes from 1 to n of j, that's n times n plus 1 over 2, plus 16 over n cubed times the sum as j goes from 1 to n of j squared, and that's n times n plus 1 times 2n plus 1 all over 6. Now, let's simplify what we can. These n's cancel out. The 16 and the 2 will cancel. That'll leave us with an 8 up here in the numerator. And I can pull a 2 out of both the 16 and the 6. That'll leave me with an 8 on the top and a 3 on the bottom. Now, let me just rewrite and simplify a little bit. What we're left with is 2 plus 8 times n plus 1 over n squared plus 8 times n plus 1 times 2n plus 1 over 3n cubed. Now remember, the integral from 1 to 3 of f of x dx is the limit as n approaches infinity of the right-hand sums with n rectangles, which we just found. So all we have to do is take a limit of those fractions and add them together. The limit of the first term is 2, because it's constant. Now, the second term looks like a rational function. The numerator is a polynomial, the denominator is a polynomial. The leading coefficient in the numerator would be the coefficient of the n squared term when we multiplied it out. I'm not going to bother multiplying the whole thing out because I know the leading coefficient will be 8. The leading coefficient in the denominator is 1. Plus our last term, also a rational function, polynomial over polynomial. The degree at the top would be 3 when I multiply the n times the 2n. And the leading coefficient, which would be the n cubed term, would be 8 times 2 is 16. So when I multiply this out, 8n times 2n will give me 16n cubed. So 16 is the leading coefficient at the top. 3 is the leading coefficient in the denominator. And we're home free. 2 plus 8 over 1 is 10. plus 16 over 3. Of course, 10 is 30 over 3, so we get 46 over 3. So that's the integral from 1 to 3 of 2x squared minus 1 dx.